This podcast is brought to you by Infrastructure Masons, uniting builders for the digital future.
One, two, three, four.
Looking to turn your innovative idea into the next big thing in digital infrastructure? The iMasons Incubator is here to help you connect with industry leaders, spark awareness, and accelerate your path to success. If your concept can help drive a more sustainable digital future, we want to hear from you. Don't miss this chance to grow, give back, and shape the digital landscape. Email us today at innovation@imasons.org to find out how the iMasons Incubator can help bring your idea to the world.
Dive into the world of data center innovation with the iMasons podcast, discovering the people leading the industry revolution. My name is Romain Tranchant, and today I'm joined by Markus Gerber, Senior Business Development at nVent. nVent offers a modular portfolio of data center and networking solutions. We are focusing on the cooling equipment that are now occupying the white space, from in-row coolers all the way to immersion. Markus has accepted to share his experience on how operators can optimize their CapEx when preparing for liquid cooling. Let's get right into it.
Okay, thank you for having me.
Markus, that's such a pleasure. It's nice to see, first of all, somebody very knowledgeable about the market when we're talking about liquid cooling end to end, but also a company that offers so many varied products that fits into different categories. And I'm hopeful that today we're going to get a sense as to a great path and the different options that people have, but also maybe how the decisions are being made around choosing the right cooling technologies for the right different types of environments. But before we get there, I'd like you to maybe introduce yourself, introduce your company so that we get to know you a bit better.
Yes, so straightforward. My name is Markus Gerber. You probably hear it. I'm based out of Germany, working in the industry more than 15 years around data centers. And yes, it's always nice because there is so much changes and movements on that market. That's perfect. You already mentioned nVent. nVent is a US-based company. And yes, we are basically, we connect and protect. That's what we do around electronics. And the clear focus is data centers, data center white space. So cooling and power, as well as the racks.
That's fantastic. Thanks for the introduction. I think that sets us up nicely for the next question. One of the things that we see is that moving away from something very traditional, like having cryo units in the room and the air-cooled environment, has seen the rise in the total cost of ownership for operators. Could you maybe take us through why is it that the cost is going up and the sort of different aspects that are making this up?
Yeah, so I think it's a bit of a relation. So in the past, the densities have been much lower, and especially you mentioned the computer room air conditioner and the containment systems. Just looking a few years back, this was ramping up, and the densities were around 5 to 10 kilowatts per rack. In today's world, the new compute, the new server generations, they're more power hungry. So we have to pack much more power into a single rack, which then, of course, from the rack perspective, increases the CapEx, first thing. I'm not sure about the OpEx, but I think we will get there. We will discuss a little bit further when we are looking into the technologies.
Yeah, we see we see a real change at the moment between prior to seeing liquid cooling become more of the norm. where operators will literally just build a standard thing between 5 to 10 kilowatt a rack, depending, and as time goes on with the higher densities. And what you were explaining to me as we were preparing this this podcast was, this is now reversed. So this is no longer operators saying that's how we build, that's the best way to do it, but actually the IT manufacturers are now dictating, you know, what their equipment actually needs to operate.
Yeah, so this is definitely a change. I would say historically, and I was thinking about this after our first discussion. It's always driven by the, let's say, the nameplate of the server equipment, even in the past, but the dates changed, so the data changed on the nameplate. So I can give you a simple example. So you always had the rating of the power supply. You always had the rating, the CFM kilowatt needed on the server. Just now with the new generations, this gets, it's exploding in a way that you have to put these things in a new way of cooling, or in a change design. And I also think the application gives the equipment, and then it's normally we as a company, we are coming in on the design infrastructure side. Someone else says, oh, we want to run this application, whether it's cloud, whether it's an email server, and that's what we need to do it. And then someone on the facility side get challenged and said, oh, this is what you have to install. And then someone says, yes, but have you just considered about the power consumption? Have you just considered about the cooling? And then the other guy says, no, I'm thinking my application. So if it makes sense.
Absolutely. It strikes me, though, that depending on who owns the facility, whether it's a colocation operator or an enterprise owned facility, that the decision making around what cooling types and the designs that goes into the makeup of that facility are going to be very different.
Yes, so there is just a little bit of rough data on there. When we look the European landscape on data centers, I would say 80% number-wise of data centers are still enterprise data centers, while power-wise, they only it's less than 30% of the power connection. So there is a massive difference in between the multi-tenant data centers in scale and size compared to an enterprise. So that's the first thing. And enterprise data centers tend to be slower by enterprise process. So very often they are looking, they have an idea on the application on what they want to achieve, but getting this quickly installed might be a challenge. So that's why the collocators are growing, scaling to host and support some applications, especially new applications talking around AI or cloud services for those enterprises.
Do you think what do you think is the makeup of the reasons why enterprise are actually getting slower? What's slowing them down? Because technically they own everything, so they should be able to be a lot more agile than a colo operator.
Yeah, it's basically two things. I would say the first thing, as mentioned, is their internal processes. Getting things done sometimes is a little bit complicated, and being fair, that most of these companies are not IT companies, so their business purpose is something else, and IT is something they need to just to execute their business. And then the second thing is when we looked at this massive amount of data centers on the enterprise level, but the time they are building a new one is probably like 20 years, 30 years in some cases, a new data center. And that's a challenge. If you've done your design, and that brings us back to the total cost of ownership discussion and doing it right, at one point you have to freeze your design and take a decision. And a data center built 15 years back will not be able to support the new server generation and changed landscape on the compute side. And I think in that regards that the multi-tenant data centers offer a very good alternative, getting the compute installed somewhere else. So it's still the enterprise company deciding on the compute to be used, but the infrastructure around is bought by a different by the colocation company.
So, as a colocation company, what are the things they do that makes them far more agile? Do they employ any specific techniques? Do they think about their equipment differently to an enterprise one? What is it? Because technically and on paper, they should be far slower, but yet your view of the market is actually very different. You're saying yourself they are able to make decisions far quicker and to actually answer to the demand, as and when the demand arises.
Yeah. So first there was a massive explosion on different sites, and if you look the mega projects going on and the investments going on in Europe, you even see governmental institutions that are involved. So that's the investment side. So there is massive money put into that market, and I think the new sites and the sites they have, they follow the new technologies. They have seen, they are early adopters in a way. So they have seen, okay, the containment system is maybe a good thing, but let's shift to the next. Let's add an inroad to the containment to increase the density. Oh, now we are reaching a level on a rack which goes up to 40 kilowatt, 50 kilowatt per rack, still air cooled, but it's not efficient and even realistic to do this with an in-row or containment. That's the point where they are moving into a rear door solution. And yes, they have these technicians, they have these people on board, making them scale. And then the other advantage they have is they can, that's also the nature of the business. They can host and consolidate different companies at one site. So we see a lot of new build investments, and we also see changing existing sites, especially with the rear door cooling, which what we call indirect liquid cooling. It's a heat exchanger on the rear side of the rack. So moving from the room to the rack in with the cooling system that really allows to optimize temperatures, especially compared to the room layout, being on higher liquid, being on higher air, being on higher densities, which of course also is a benefit when you look at efficiency and the POE and the water usage efficiency of those systems. That's a bit of buzzwords throwing out there, but in a nutshell, the rear door allows you to operate on higher temperatures, be more efficient, and address the higher densities in the rack.
Is there anything that those colocation players are doing to, I would say, prepare themselves for what's coming up? We know, in all the types of markets, especially electrical distributions, that people will bank on and buy ahead of time and so on. Do you see the same sort of trends in the cooling side?
Yes, So you can separate it again a little bit. So on the enterprise side, it's like, oh, we want to have this new application. Someone took a decision on a service, and then someone have to execute. On the colocation side, their business is to sell the space, so they have to make an assumption what is the next requirement coming from their clients. So that's why
Yep.
they're getting prepared, and then they can go and if an enterprise says, "Oh, where I'm going to put this application now," then it's a race, and they say, "Well, look, my facility is ready. Just let me know when you want to get started." That's the I would say that's the benefit of the rear door, and I think we have not talked about direct liquid cooling, cold plate cooling, and that is a bit more challenging, I would say, because it's not something you can as easy retrofit into an existing site. So very often it needs to be a purpose-built white space for this application, because what you do now is you move from the rack-based cooling, you move into the server. So you're getting even closer to the heat with those systems. And here you need normally it's operated on a coolant distribution unit, which is, in a nutshell, it's a liquid to liquid heat exchanger building up a secondary pipe work of liquid to cool down the equipment with integrated cold plates. And therefore you need it first, a very clean secondary pipe work. There should not be any dirt or corrosion or anything inside. So you need additives, because the cold plates, the pipes in the cold plates are very small, and you don't want to lose your cooling or risk a performance drop. Then you have to add additional distribution equipment, the manifolds inside the rack. So you're interfering into the rack now. You are getting with your infrastructure closer to the equipment, which was historically always a cut facility. IT was separated, and then really getting back to the beginning, and that's the main challenge, is the manufacturer of this compute. They have to put data on their labels. So now we are not talking CFM per kilowatt. Now we are talking pressure and flow of liquid and temperatures, and that's not yet fully standardized. So everyone is giving his own values, kind of. What makes it difficult to plan just a vendor neutral direct to chip cooling loop.
So when you're having discussions with your clients looking at those new facilities or retrofits, where do they start? What's their key concern when they want to change the cooling requirements? And admittedly, they have to, as densities are rising up, otherwise they might not be relevant for the market anymore. But where do they start? What's their primary concerns there?
You can separate it, but that's always the thing in every market. You will have people which say, "Oh, I'm doing this job since 20 years. I'm not going to change the way I'm doing it." So that's the first. That's always the first ones to come and say, "No, it's okay to have liquid in your white space. You don't have to do it with air." So that's the first thing, and then it brings down. I don't want to make any promotion on a specific vendor, but it's quite obvious when you look at the new NVIDIA complete rack with Blackwell liquid cooled chips. Then this is the NVL72 as an example. This goes up to 130 kilowatt in a single rack. So if someone says, I need one of those for whatever reason, then you have to bring it in. You have to support it on the infrastructure side, which is it can be a challenge. But said this, I think when we talked, there was another interim solution, because I was talking the educated layout, let's say, on a direct-to-chip cooling circuit. There is an interim technology which we call liquid to air, which is efficiency-wise, it's maybe not the best thing, but what we do is we pump liquid through the cold plates, and then we transfer the heat back to an air circuit. Now you could say, whoa, that's liquid, air, liquid, and you're changing the medium quite often. So yes, that's right. So, but what you can do is install those new technologies very quick into an existing site, and that's also something. Yes, we are looking, because then you reduce your planning outlay from basically 6, 9, even 12 months down to 8 weeks, which is
Right.
yeah, which is another thing to consider.
I mean, if I get that right, what you're saying is there is a real reluctance to actually move to something more innovative. And we've been talking to manufacturers that are doing immersion cooling, and even the direct to chip is somewhat innovative for some, or a little bit too further forward for some. But what you're saying is that we're now finding solutions that are halfway house, getting people comfortable with what's going on, also eliminating some of the problems of retrofit, which would see a lot of pipe work going down to some extent at the detriment of maybe PUE or various other efficiency metrics. Is that where the world is going right now?
I would say it depends. So this is always a business decision. So someone who have to get something up and running, you have to probably pay a little bit more on the investment side, and accept having a higher operational costs. So I would say yes, it's an interim solution. And now I'm thinking a little bit sustainable. If you have the chance to buy yourself some time, then it's definitely better to make it on a CDU, coolant distribution unit, liquid to liquid. However, sometimes, and we all know this, in private and professional life, sometimes we have to be quick to achieve a certain goal. You mentioned the immersion as a last step, I would call it, and that is clearly something personally I'm a big supporter, because what we do is we get completely rid of any air. Liquid has a much higher cooling capacity than water. It's much more efficient to work on pure liquids. However, we see the market currently not is fully going in that direction. And even looking at, I mentioned the planning outlay of new, even large data centers, they sometimes talk 12 months and even longer. So we are on projects which shall be installed in 2027, and then we are working on it right now. And these ones, they all go down to the direct to chip instead of immersion. So it will. I'm sorry to say that, and some people might disagree with my statement, but that's also the nature of a discussion. I think it will take a few more years until immersion it's getting into scale. And
Yeah, there was a lot of wishful thinking. Yeah, I know, and so are many people about immersion. I think the facility side of the equation has not really pushed back on it. But we must say the adoption side is not really down to the person providing the facility, but really the occupier really wanting that technology for themselves. We've gone through the decision making. We've gone through, especially on the colocation and enterprise side. What would be the best advice you can give to operators today to maybe make quicker decisions, better decisions in terms of how they plan and build the facilities up from a cooling perspective?
So I would clearly say, if possible, think about what you want to achieve and how long you want to operate the data center site. And because there are still applications that might not require direct to chip. So there is no need to just to try and get it up and running. On the other hand, just follow a little bit on, and brings me back to the server and the compute side. Just follow a little bit what happens there. And I think we also have a liquid cooled gaming PC staying around somewhere in the house. So just think in that directive. So it gonna happen, and you should be prepared on when you make your design and layout and be a bit more open and educate yourself. It's not bad to talk to manufacturer like I'm talking to competition. They know what happens, and there is a lot of design and consulting which can also clearly help. That's one thing. And personally, I'm thinking, and that's something where we put also our focus on, is the advanced control of the cooling technologies, because with getting that higher technologies, moving closer to the compute, there is also the risk factor is getting higher. So in case you have a failure, the rack will heat up immediately. So make a proper monitoring of your devices, even connect them together, and that would be a wish, and make a kind of machine learning on your cooling system to improve it to whatever weather conditions, site conditions, allowing you to play a little bit. Also increase the temperature. Will it really help? Will I really save money by doing this? Is my PUE getting better? Reducing it, and that's things I would personally like to see more people looking into this advanced control and monitoring options.
It's an interesting point you bring forward, because not many people actually mentioned it. Everybody talks about deploying equipment, getting them to run, but not many people are really looking at, well, how do we monitor those things? Do we need to monitor them differently? Do we need to optimize them differently? You're mentioning machine learning in terms of like controlling those equipments to really get the full on benefit of those installations. That was such a sensible point to actually bring to the operators and bring us to a close to this podcast. Markus, thank you very much for all your insights and sharing with us your view of the market. For those of you as listeners who are interested in connecting with Markus or nVent, we've put the URL on the screen. If you're listening to us, go to nVent.com, where you can find all the information. I'm pretty sure you will be able to find Markus on LinkedIn as well if you want to reach out. On my side, I personally want to thank you very much for coming on the podcast. The discussion will carry on iMasons.mobilize.io, which is the internal iMasons platform. If you're not already a member, please go ahead and sign up to actually benefit from discussions such as those ones. And until next time, thank you very much, Markus, and we'll see you soon.
Yes, thank you.
1, 2, 3, 4.
Infrastructure Masons is a global, non-profit, professional association of individuals connected and empowered to build a greater digital future for all. If you too want access to networking events, forums, and summits that foster innovation and influence, register now and join the other 6,000 committed participants at imasons.org/membership application.